Welcome to Echo 302, Study Session 8, Interest Rate and Equilibrium in the Money Market, the LM Relation. Introduction. In the last lecture, we said that interest rate is a strong determinant of national income. We also showed that there is an inverse relationship between income and real interest rate, but the interest rate referred to is taken as exogenous in the product market. Meanwhile, interest rate is strongly influenced by the activities of the money market. That is, demand for and supply of money actually determines and is determined by interest rate. Thus, the interest rate taken as given in the product market is determined in the money market, and as it stands, we need to understand how this is determined. Also, demand for money has a strong bearing on the level of income. For instance, a rise in the demand for money will, all things being equal, increase spending and hence raises aggregate income. Therefore, it appears that both interest rates and level of income have strong implications in the money market. Besides, there appears to be a relationship between interest rates and income in the money market. This chapter would discuss how national income and interest rate are being influenced by monetary instruments. Objectives. At the end of this lecture, we should be able to 1. Explain the various drivers of money demand. 2. Explain why money supply is exogenous. 3. Graphically and algebraically derive the LM curve. 4. Show how and why is LM upward sloping. And 5. Determine factors that shift the LM curve. Money market, money demand. Let us assume that we are living in a world where individuals' wealth can only be held in form of money or bond. Suppose that creation of money and bond is the sole responsibility of the government. Furthermore, let money be considered as amount held in form of cash. That is, money does not earn interest. The question we intend to provide answer to is that if wealth may be held in an interest-bearing asset, why should people choose to hold cash which does not bear interest? People hold money because they need it to buy intermediate or final goods. Also, people hold money to guide against unexpected spending. Finally, people hold money if bond price is expected to fall in the future. These three purposes form the components of money demand. Let us explore further on these. Determinants of transaction and precautionary balances. We recall that consumption is positively related to income. Also, the volume of cash to be held will be influenced by the volume of transactions in goods and services. This implies that the relationship between cash held and the volume of transaction is strong and positive. Meanwhile, the strongest depends on the velocity of circulation. Velocity of circulation is defined as a measure of how hard each unit of currency is made to work. With a constant velocity, an increased volume of transaction will increase the cash requirement. Hence, transaction balances depend positively on the level of income. Another determinant of transaction and precautionary balances is interest rate. If the interest rate paid on bond holding is high, the opportunity cost of holding money will be very high, and therefore people will tend to put their money in bond and choose to sell bonds when they need cash for transaction. However, frequent conversion of bonds to cash within a short period of transaction will likely reduce the benefit of high interest rates. Also, if the conversion is to be done through a broker, it will attract brokerage fee but reduce cost of frequent cashing. Individuals then determine the trade-off between high interest rates and the brokerage cost. If interest rates surpasses brokerage costs, individuals will wish to put money in bonds, thus reducing average cash holding. Therefore, demand for transactional balances depend on income level and rate of interest. Baumol-Tobin transaction balances. Another way of looking at the determinant of transaction balances is the use of Baumol-Tobin model. Assuming that an individual earns Y amount of income per month and the entire money is deposited in his commercial bank account, this amount is expected to serve its transaction purpose. To draw on the account, he makes personal trips to the bank at a cost of K per trip. The individual makes consistent visits to the banks and the same amount of money is drawn up per trip. This implies that the average monthly balance is that which is in halfway through the month. The average balance is Y by 2. Let the amount withdrawn be A, so that the amount of visit will be Y over A. Let us think that the amount withdrawn per time, A, is spent uniformly, so that average cash holding will be A over 2. Hence, the interest lost on cash held for the month will be RA over 2. With this information, we can calculate the cost of converting the deposit to cash, and this gives C equals FA plus R times A over 2. That is, cost of conversion is the sum of cost of trips to bank and the interest rate cost based on average monthly holding. The individual then will need to choose the size of withdrawal at the minimum value of C. That is, DC by DA equals minus K times Y over A to power 2 plus R over 2 equals 0. Minus K times Y over A to power 2 equals minus R over 2. Minus 2KY equals minus R A to power 2. A to power 2 equals 2KY over R. A equals square root of 2KY over R. This formula is referred to the square root formula. As we can see, A, which is thought of as demand for money, is an increasing function of income and a decreasing function of interest rate, determinants of speculative balances. There are many ways of showing the influence of interest rate on speculative demand. In this section, we shall restrict ourselves to one. Speculative demand takes place in the bonds market, and therefore we need to consider the market for bond first. Let us assume that there is only one bond, and this bond exists infinitely and may be bought and sold in the bond market. Government pays the bond bearer a fixed amount, say T, in each period. We assume that bond price, PB, equals the total discounted value of the strings of TS. As usual, we need to compute the present value of TS. From our experience, we know that the present value of T will be given by T over 1 plus R. Now, let us assume that there is a choice of receiving A amount today or receiving T in the future. Let us think that if A is received today, it is going to be financed in bond, and this will yield R interest rate. In this case, the value of A and T should be the same in 1 year. That is, A plus RA equals T. A of 1 plus R equals T. A equals 1 over 1 plus R times T. Meaning that the present value of T in 1 year is A as given by equation 8.4. In 2 years' time, we present the value of T is T divided by 1 plus R in bracket to power 2 and so on, since the bond pays T in each future period forever. The total present value is stated. Equation 8.5 gives the total discounted value of the stream of Y, and this is the price of bond. That is, PB equals TR. It is clear that bond price and interest rate are inversely related. What this implies is that an individual willing to purchase bond will do so when the price falls. The speculations enter the scene because the individual must choose when to act appropriately. Purchase bond because he believes the price of the bond cannot be lower than the price he purchased it, and sell bond because he believes the price of the bond cannot rise further. Thus, the lower the interest rate, the higher the price of bond, and the more likely will people be expecting it to rise, and the more cash is held in anticipation. From both transaction precautionary and speculative balances, level of income is a strong driver of the former, while interest rate is a fundamental driver of the latter. Generally, demand for money balances is positively related to income and inversely related to interest rate. Further, for a given level of money demand, when transactionary balances or precautionary balances rise, speculative balances will fall. Conversely, transactionary precautionary balances will fall when speculative balances rise for a given level of money demand. The LM relation. Graphical exposition of equilibrium in the money market. The equilibrium in the money market requires that money demand equals money supply. Assuming that money supply is predetermined unilaterally, determined by the monetary authority, we can use a 4-quadrant graph to illustrate the level of interest rate and income that will clear the money market, given the analysis of the determinants of money demand presented above. This is presented in figure 8.1. In quadrant 1, the speculative demand for money is plotted. It shows the inverse relationship between speculative money demand and interest rate. Quadrant 2 shows how individuals allocate its cash between transaction balances, TR, and speculative SP. At low interest rate, individual demand for money in anticipation of higher interest rate in the future. This lowers transaction balances for a particular level of money balance. The third quadrant shows that increase in income leads to increase in transaction balances, and quadrant 4 shows the combination of interest and income for which money market is at equilibrium. For instance, when R equals I2, speculative demand falls, and since wealth is either held in cash or bond, for a fall in speculative demand, transactionary demand rises. An increase in transaction demand leads to increase in expenditure, and since at equilibrium, Aggregate expenditure is equal to aggregate income. Y increases. When we trace this down to quadrant 4, we arrive at I2, which satisfies Y2 to leave money market at equilibrium. The line that connects this point is called LM curve. As we can verify from graph, LM curve slopes upward, indicating that when interest rate rises, demand for speculative money and demand for transactionary money will fall. Increase in transactionary demand as income rises will lead to a rise in interest rates, which in turn leads to increase in output. We can also derive IS curve in a very simple two-graph diagram. This is presented in figure 8.2, where at a fixed money supply, money demand, which slopes downward, shifts as transaction or speculative balances change. As observed in figure 8.2, we see that LM curve slopes upward as well. Let MT represent algebraic exposition of LM curve. Let MT represent transactionary demand, while MP represent speculative demand. In view of our discussion, we have MD equals MD of YR times M, which is greater than 0, and MP less than 0. That is, money demand is a function of income and interest rate, with transaction balances increasing in income and speculative balances decreasing in interest rate. Money supply, on the other hand, is assumed to be fixed. Let us call it M. Equilibrium in the money market requires the equilibrium of the demand for and supply of money. Hence, MS equals MD equals MD of YR. It follows from our discussion that for a given income level, the equilibrium in the money market is certainly determined by the equilibrium interest rate. MS equals MD equals MD of Y and R asterisk. We also know from the graphical exposition that variation in R equilibrium will lead to variation in income if equality is to be maintained. Thus, equation 8.9 implicitly gives R asterisk, that is, R equilibrium as a function of Y, just as the equation 7.4 implicitly gave equilibrium Y as a function of R. Equation 8.9 is called LM function. It shows the combination of interest rate and income, which gives equilibrium in the money market. Taking total derivative of equation 8.9, we have dms equals dy of y and r asterisk dy plus dr asterisk of y r asterisk bracket close dr asterisk. Now, by our assumption, dms is 0, so that we have 0 equals dy of y and r asterisk dy plus dr asterisk of y r asterisk bracket close times dr asterisk. Hence, dy of y r asterisk dy equals dr asterisk of y and r asterisk in bracket dr asterisk. Divide both sides by dy and by dr asterisk and simplify. Minus dy of y r asterisk in bracket divided by dr of y r asterisk, which gives us dr asterisk over dy. Equation 8.11 gives the LM relation, and as we see, it is positive. Now, Let us make an explicit specification of LM relation. Let money demand be represented as follows. MD equals MT plus MP. MT equals alpha plus lambda Y. MP equals theta minus RR. At equilibrium, MS equals MD equals M. M equals alpha plus lambda Y. MP plus alpha minus beta R. So we have M equals V plus lambda Y minus beta R. M minus V minus lambda Y equals minus beta R. V plus lambda Y minus M equals beta R. R asterisk equals 1 times open bracket V plus lambda Y minus M divided by beta. It can easily be demonstrated that the slope of LM is positive. Effect of monetary policy on LM relation. Let us begin by inspecting what happens if money supply changes. For instance, assuming the monetary authority increases the money in circulation, particularly by printing new notes. This can occur if the government intends to finance its budget by printing money. Using equation 8.1, we see that holding income constant, dm equals 0, dr asterisk of y, r asterisk in bracket, times dr asterisk. And by simple manipulation, dr asterisk over dm equals 1 over dr times y times r asterisk, which is less than 0. That is, an increase in money supply, holding income fixed, reduces interest rate. We can also confirm this inverse relationship using equation 8.12. The graphical representation of equation 8.13 is shown in figure 8.3 below. The graphical representation shows that for a given level of income, changes in money supply reduces equilibrium interest and thus shift the LM curve downwards and parallel to itself. What happens if R is greater than or less than R asterisk? Point above R asterisk, that is equilibrium R, say point like A, in figure 8.2 is an example. In this case, money supply is less than money demand. To bring the situation back along the LM curve, money supply needs to increase. The first line states that there exists excess supply of money, while the second line says there exists excess money demand. Trace equilibrium Y to a point like A in figure 8.2. At that point, money supply is greater than money demand to consume output at equilibrium. Thus, there is excess money supply. At point like C, money supply to the economy is not enough in demand for economy's output, resulting in excess demand for money. Thus, point to the left and above the LM curve will lead to excess supply of money, while points to the right and below the LM curve will lead to excess demand for money. Any point along the LM curve shows that money supply is just enough for demand for money, which will be used for purchasing the economy's output. Summary: equilibrium in the money market requires that there is a specific level of interest rate associated with a particular level of income. LM curve is upward sloping, indicating that increase in interest rate will require increase in income to ascertain equilibrium in the money market. The channel through which interest rate leads to increased function in income are speculative and transactionary demand for money. Money supply is assumed to be determined by the monetary authority and therefore treated constantly. Increase in the autonomous money supply, holding income constant, will reduce interest rate for equilibrium to be maintained in the money market. A point to the left and above LM curve indicates excess money supply for a particular income level. To restore equilibrium, interest rate will have to fall. LM curve is useful in analyzing the effect of monetary policy on the economy. In the next lecture, we shall use both IS and LM curves to shed more light on critical macroeconomic issues, particularly when the issue has to do with fiscal and monetary policies. This is the end of study session 8. Thanks for listening.